So in this video we are going to discuss about the young double slit experiment. Okay, that is totally based on the interference. Okay, so as you guys all know, we have discussed about the interference a lot. So what is young double slit? This is basically, there was a scientist in 1801, Thames Young. Okay, he performed the young double slit. Okay, and that is basically also proving the wave nature of light, that light is having wave nature. Okay, and this is basically based on the division of the wave front. So as you guys all know what is wave front, let me give you introduction. As you guys all know, we have in the previous video discussed about a lot of things about the wave front. For example, this is the, so these are what, these are the, this is the, for example, this is the source, and from where this, or all the things is there. Okay, so wavefront is basically the phase where the light is basically emitting. Okay, so here the wavefront is spherical if it's not away from the source. If it's away from the source, so it is like the plane surface will be there, plane. Okay, so the angle between both will be 90-degree angle. Okay, if you talk about the division on the wavefront, that is in the, as you guys all know, in the north south, west, east. So these are what, the source of light is in the different direction. Okay, or in the wave nature of light. Okay, so if you talk about the source of light, we are having the source of light, like you can say that we are having monochromatin or the chromatic. What does that mean? It means the single color. The source will be having the same color, wavelength, frequency, energy will be same. Okay, we can see the interference by this light, monochromatic, single light. You can say from Vibgyor you can take any single light like red, blue, orange, green, any one color. Mono means one, chromatin light, only one color. If you talk about the polychromatin, so that will be, you can see that many colors, many lights, like visible light, that is having the 7 colors. So that you can see that will the polychromatic. But we are here in young double slit, that is based on the interference, and interference is based on this one source, that is monochromatin. Okay, so here for example I'm having the slit source 1, source 2. I'm having the slit, and this is the source where the light will be coming. This is the slit I have recorded, and here I am having the screen. Okay. So from this is what, this is the distance between source 1 and 2, and this is the distance between the slit and the screen, capital D. So here source of light, some light will be coming from the here side like this, and some will be coming by here like this. So here you can see that the intersecting point between both lines, that we are calling as a bright fringe or the constructive interference. Constructive interference. And here you can see that these are the empty space, so that we are calling as a dark fringe or as a destructive interference. Okay. And here you can see that here we are having the, this is what, this is the spot basically appeared after the interference, that the interference pattern you will see in the screen. You can will see the interference pattern. So that is showing that is the bright fringe or the constructive, from where the light will be shown. And here this is empty space, that will call as a destructive, which means no light. Okay, so interference is basically visible by the source of chromatin, which means single light. Okay, let me tell you guys about the constructive and destructive once more. Okay, constructive means, like for example, this is a wave and this is a wave. The crust will move to crust. So a bigger wave will be produced, that will be having a more amplitude, which means height. So that wave will be maxima, which is maximum. If we talk about the destructive, for example, this is a wave and this is a wave. Here you can see that the crust and trough cannot match because the sizes are up, like the phases are opposite. So here you can see that their dark fringe will occur, and here the more wavelength will occur, which means bright fringes. So here you can see, we can say that that is minima, which means the maximum wave will be produced. So this is about the that thing. Okay, let me make another slit. Okay, for example, this is a slit, and here is the source 1 and here is the source 2, and here I am having the screen. Okay, so from this source, for example, I am having this one point. This point is basically, you can say that origin point. I'm taking here is the origin point. Okay, so here I can say that source of light on this, source of light on this, which means the distance between both are same. So I can say that this R1, R2, both are same. Okay, and here is there is a source, which is the distance d between source 1 and 2. Here is the distance d. Okay, so this is the ray nature of light I am talking about. The ray nature of light we are talking about. So if we talk about the path difference is between the extra distance. Here the triangle is perfect, which means here the extra distance is 0, which means 0 at the center. Okay, so I can say that R1 and R2 are the 0. Okay, so here you can see that here I am having the readings like 1, 2, 3, minus 1, minus 2, minus 3. So that will show the reading of the bright fringe. Okay, so to find the bright fringe and the dark fringe, we are having the young double slit experiment. Okay, so if we talk about the path difference, okay, what is path difference first of all? For example, this is the slit. Okay, source 1, source 2, this is the screen. Okay, for example, I am having the point P, and the light from the source is moving here, and the light from this source is moving here. So here you can see that the extra distance is there. Okay, this is the triangle, for example, and this is what? This is the extra distance. So the extra distance, we are calling that as a path difference. Path difference. If I am making this angle here like this, okay, so that will be the 90-degree angle, like hypotenuse, base, perpendicular, ACB, ABC. Okay, so here you can see that that AB. So path difference is having a formula that is n lambda. N lambda. So from path difference we will make the, you can say that the bright fringes formula and the dark fringes formula. Like that, for example, I can say that this is the, here I am taking the perpendicular. How? You can see that here the from the AB, you can take the example of the AB. Okay, A and B, which is equal to the D. I can say that A and B are equal to the distance D, or you can say the D, which is the source of light, these both D. Okay, and I can say that A and C, which is the path difference. Okay, A and C, A and C, here I am taking A and C as a P perpendicular, which is this. So I can say that the path difference. So I am here using the formula that is the sine theta, which is perpendicular upon hypotenuse, because I have to find the bright fringes. So I can write a perpendicular, which is equal to the AC, and hypotenuse, which is equal to the, you can say that hypotenuse, this is the D. Okay, so I can write here D. So here you can see that I can write here that AC is equal to D sine theta, and I can write here that n lambda, okay, is equal to the D sine theta. Okay, AC we have taken as a path difference. Okay, path difference. So here I can write as n lambda is equal to D sine theta. So this is the formula for the bright fringes. If we talk about the dark fringes, So we are having the formula of the dark fringes like d is equal to sine theta is equal to n plus half of the lambda. Okay, for example, I have taken that d as a path difference. Okay, so this is what, this is the d, which is the path difference, which means like this. So we have taken here path difference and AC, which is the perpendicular, like this is a perpendicular, so we have taken as a p as a perpendicular, and here we have taken the d, so that's why I put in as a sine theta, which is perpendicular upon hypotenuse. Okay, so this is the formula of the dark fringes. For example, I'm taking here the integer I'm taking here, for example 2. Okay, so you can write it d sine theta is equal to the integer 2 plus 1 is equal to lambda, and is equal to the that 4 plus 1 2 is equal to 5 upon 2, which means 2.5. So here, which means 2.5, which means this is the center, this is the between this 2.5 here. So these are what, these are the bright fringes, but between them there's an empty space that we are calling it the dark fringes. So that is showing the dark fringes. So this is the formula about the dark fringes. Okay, so part difference and the angle of the this one will be same. Like for example, this is the thing, so here the angle and here the angle will be, both will be same. Okay, so that today we have derived the formula of the part difference. Okay, so in the next video we will discuss about the position of the bright and the dark fringes. Okay, then we will find the position formula. From that you will easily find solve the problems if someone is asked you to find the bright fringes and dark fringes, so you can easily find that. So that we will discuss in the next video.